If you take 4 plus 1, you get 5. Simple addition. But vectors are different. Vector addition is different. So if you take 4 plus 1 and they're in the same direction, you get 5. And if they're in the opposite direction, 4 plus 1 gives you 3. And the direction matters. So you don't just get 4 plus 1 gives you 5. You get 4 plus 1 gives you 5 in that direction. You don't just get 4 plus 1 opposite gives you 3. You get 4 plus 1 opposite gives you 3 in the direction of the big one. And if you take 4 plus 1 and make a little triangle, then you get a completely different value in a completely different direction. So the direction really, really, really counts. A vector of 4 and a vector of 1, depending on the direction, you could get anywhere from 4 minus 1, 3 to 5. Anything. Infinite number of possibilities from 3 to 5 in any direction imaginable. That's just the way it is. Now there are 4 methods that I tested using, and while I was in Paraguay this summer, I spent some time and didn't do a lot, but addition of vectors, comparison. 4 methods there, and a 5th one that I just invented right now, but 5 methods of vector addition. A comparison of all of them. What are the advantages? What are the disadvantages? Which one's the best? Let's learn physics. For vector addition, you could use a calculator, or you could use a bunch of tools like this. So here's the problem. 600 newtons at 120 degrees plus 400 newtons at 190 degrees plus 800 newtons at 310 degrees. This works for any kind of vector and not just forces. Accelerations, velocities, momenta, it's all exactly the same thing. Now the fast trig version, not the fastest trig version because I just realized that there's a better one. But anyway, the fast trig version is something like this. If you just take 600 times the cosine of 120, you get the negative 300. 600 times the sine of 120, you get 520. You put these numbers here in the proper x and y columns. And if you are using these angles from the 0 is at 0, and then counterclockwise from there, that's 90, this is 180. If you're using that correctly, the TRIG standard, then it turns out that it all works itself out in the calculator. And the calculator knows whether it's positive or negative because the cosine is associated with the x. And if it's in the first and fourth quadrant, the cosine is positive. Second and third quadrant, the cosine is negative. First and second, the sine is positive. Third and fourth, the sine is negative, and this all takes it into account. Do that method right there. The cosines in the x column, sines in the y column, get those two values, put them into a triangle, find the hypotenuse using the Pythagorean theorem, and the angle using the inverse cosine of 162 over 179, getting that angle and adding it to 180. So that one took me 3 minutes and 30 seconds total. I timed myself. I was bored. I didn't have my motorcycle yet. Second method, the slow trig method, same exact problem. So I'm doing this exact same problem here, doing the slow trig method, but sketching each of the vectors. So I sketch the vector, sketch its components real quick. Sketch the vector, sketch its components, sketch the vector, sketch its components, and then do the same thing, but use the reference angle. So 120 degrees, 60 degrees to the x. 190 degrees, 10 degrees to the x, and 310 degrees is, well, in this case, I did the y for some reason, but that's 40 degrees. 270 is 40. Get all the values, take the x's, take the x and the x and the x value, add them up. Take the y and the y and the y, add that up, and then get the negative 180 and negative 107, 180 negative and 107 negative. Gives you 208 and 211. That took me 4 minutes and 30 seconds. I realized later, because I actually had this one covered up when I was doing it, realized later that there was an error here. That 17 newtons should be a 69 newtons. So I don't know what I did. It's really difficult to check it. This one, difficult to check. But it took me 4 minutes and 30 seconds. Obviously it took longer, there was more work that I had to do. This is the purely graphical method. You take this calculator and you ignore it. And you take this and you take this and you measure stuff. I felt like drawing a 310 first and then the 190 and then the 120. You can order these in whatever way you want to because graphical addition is commutative, just like regular addition. So I took 800 newtons at 310, measured 310 degrees, 270 plus 40, and then used my scale. This is 800, so that should be exactly 8 centimeters. perfect measurements. Make sure that that is as perfect as you possibly can be. And this is as perfect as you possibly can be to make sure that that is exactly the proper length. Carefully draw the arrow back. I have other videos on this method. 400 newtons at 190, so 90, 180, 190. Measure that to be exactly 4 centimeters long. And then from there, line up the protractor again and measure 120 degrees. So line it up with all the lines, 90, 100, 110, 120, and then use the ruler, and that would be 6 total centimeters long exactly. So measure it, use my scale. I get 260 newtons at 223 degrees. And that's 4 minutes. That's pretty good. 4 minutes is right in between the other two. So 330, 430. This happens to be the slowest. My students think this is the fastest. They think this is the slowest. If you want to check those things, all you have to do is run over it with a protractor, like you would with a truck. And you take this thing, measure that angle, measure this angle, measure that angle. Make sure your angles are perfect. Then use your scale, measure, 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 make sure everything's good, and then measure this to double check, measure the angle to double check, and I did extend the line as is standard practice. You could also put this thing on here and then just with the ruler extend the line, but I wanted to extend the line visually. I also did my pre-drawing. It's a normal pre-drawing that I do just to make sure that I have enough room to fit it, because if I start over here and then it goes off the page, that's annoying. Graphical components. This was one I didn't expect. I suddenly realized, oh, well, graphical components, I could do that too. So if I do this 600 newtons and draw that perfectly with protractor and ruler, I can then draw the X and draw the Y and get 310 and 510. Just draw them, why not? And then this is the 400 newtons at 190. I measure the X to be 402, 400 also, and the Y to be 70. That was pretty close, this one's pretty close. For small angles, the hypotenuse and the long leg happen to be about the same size. And the 800, measure that. So proper direction, proper length, measure it perfectly, finish the right triangle, measure, measure, get all those values. Then take all the values together. Take the X's, the 520 in this direction, and the 400 and the 310. So 400 and 310 gives you 710. 520 leaves you with 190 in that direction. And then the 510 and 620 and 70. So 690 versus 510 leaves you with 180 in that direction. 180, 190, 180. And then measure 223 degrees with the pro. This is all measuring. There's no calculation actually done here, but simple addition. And measure the length and use the scale, 265 newtons at 223 degrees. This, of course, took twice as long as everything else, 8 total minutes. Now, here are the advantages. You have the fast trig method, 3 minutes and 30 seconds. That's the proper answer. I checked it, that's the definite answer. The slow trig method at 4:30, well, I had an error in there, and it's kind of difficult to check those errors. I'd have to go back and check each of the individual calculations. The graphical, 4 minutes. And this is actually one that I prefer because I can use this graphical with every level of class. Conceptual physics, all the way up through honors physics, I can use graphical, and I do use graphical. And this does depend on sketch precision. I am 8% off on that one. And the graphical component, 8 minutes, way too long, ridiculous, and I was 10% off on that one. This is, okay, so comparing the graphical component. This is ridiculously long, but it's conceptually the same as the slow trig method. This one, this thing, you don't do any math. It's accessible to everybody, but it's kind of weird conceptually. It does have a check. There's a good check here. Fast trig, all math, fast, no check. And then this is slower, but it's visual and it does have a check. You can go back through it, but it's the check is a bit ponderous. This one, the check is faster. It's faster, the check is faster. I prefer the graphical method for the complicated ones, and the slow trig for the less complicated one, because it is actually faster than graphical if you only have a couple of vectors, often. Anyway, that's 4. Now the 5th. Here's the fastest trig method, and it relies on an understanding of trigonometry for this. 600 cosine 120 plus 400 cosine 190 plus 800 cosine 310 gives you negative 180, which is the x component.
And then all you have to do is 600 sine 120 plus 400 sine 190 plus 800 sine 310 gives you negative 163.
So, negative 180, negative 163, draw them out here, and then use the Pythagorean theorem the really quick way.
Second function, square root of 180 squared plus 163 squared is 243. So I've got 243 newtons, and then the inverse tangent, second function tangent of 163 divided by 180 is 42.2 degrees.
180 plus 42 gives you 222 degrees. Done. That took me 1 minute and 42 seconds. That's the quickest method. The quick check is just putting the numbers back into the calculator. It does have a good check, and it is far faster than any of these other methods. That is the flash trig method, the speedy trig, the fastest trig method. This again is the one, the graphical is the one you can use for everybody. Slow trig is the one I generally use for the honors physics. Graphical components, I've never used it in class. Fast trig, I've never really used it in class except for AP physics to give them a faster method. And this is the flash trig method, which is actually faster and better than that one. I guess that's the end of the video. 5, count them, 5 methods of vector addition compared. Thanks for watching Learn Physics. And thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.